I just wanted to give a quick overview before we start the video. In this video, I'm going to discuss rebuilding the center section of a 9-inch rear end. I'm going to discuss all the problems I ran into and show the whole process in detail. The gear set I received for this rebuild did not have marked pinion depth numbers, so I had to eyeball the pinion depth with the best possible shim ratio. I have a previous rebuild video where I fully discuss using marked pinion depth that can be referenced in addition to this video. Also, I'm not perfectly set up to do case spread by measurement. I do another technique to set the preload, but I'll show a Ford manual reference later that shows the correct way to do it to spec. I also got about halfway through the rebuild and noticed the center section I was rebuilding wasn't going to work in the truck perfectly, so it was best to pull the one from the truck and rebuild it. You might notice the parts change through the video, but it will all be the same info. Besides that, the video is going to start out with important tips to look out for before starting the rebuild process. If you have any questions, just ask in the comments or below, or if you'd like to add any details I may have left out, please do. Also, I made some keychains, stickers, some hats, and some t-shirts and stuff. And this is going to be for sale on desertratracer.com. If you guys get any support from this video and want to help out, you can maybe go buy some of these things or just check out the website. All right, thank you. We just did a T5 transmission swap in it, and now the gearing we had in it was too tall. So we needed to re-gear. We didn't want the truck to be down for too long while we were, possibly looking for parts. So we thought we were going to rebuild an extra 9-inch we had laying around and swap it in. This was the extra 9-inch I had laying around. So we took it apart. I messed up the pinion housing. We bought a new pinion housing. We found out the spider gear was messed up and one of the thrush washers. So we bought that. Turned out the spider gear kit we bought was wrong. So we were gonna have to return that. The other thing we needed to double check was the yoke. This yoke is a 5-inch yoke. This is the third member out of the truck now. So we thought we could take the yoke off of it and put it on this one. Well, not only is this the older style, which we knew that it takes a different seal, but apparently this pinion housing is different, possibly an original style Daytona housing to where the depths are different. So then it takes a different yoke. So this yoke will not fit on here. So we were just snowballing on this one, needing another yoke, needing spider gears, things like that. We could possibly do a drive shaft to fix the problem, but we just put in a custom drive shaft because of the new transmission. So that's not really an option. But the spacing on this case is different, and then the measurements are just off with no matter what yoke we use. So we almost have to use this case and this pinion housing and this yoke to fit back in the truck perfectly like the way it needs to be. So hopefully we can use our rebuild kit on this. We already have a seal and some other stuff, but for right now I'm just going to go ahead and take this apart. You might see me pick it back up by installing the yoke and setting the pinion preload. It just might be with a different case and different housing and stuff like that, but I'll pick right back up where I left off after I get all this apart and figure out what I'm doing. I've rebuilt some rear ends in the past, but this 9-inch this time around just threw me through a loop. So I just wanted to help people out if I could. The first thing I want to talk about is if you have a 9-inch in a vehicle and you know it's good, I kind of recommend using what you know works with the vehicle. We had a 9-inch in this and we had a custom drive shaft made and it worked. Put in a T5 transmission behind the flathead in this truck. So we ended up putting in a custom drive shaft that fit the rear end perfectly. But then the gearing was too tall, so we needed to put lower gearing in the truck. Ultimately, I went and took another third member we had laying around to rebuild that and put it in the truck. It turned out that opened up a lot of problems that we ran into because this had a specific yoke length with a specific pinion support on a certain case that affected the length of where the drive shaft would hook up, among other problems that we ran into. So that's basically my first tip. Unless you're repairing a rear end that is broken in an existing vehicle, if you're going to just swap gears, I suggest using the gear set that you know works with your vehicle. If you know you have a good combination of parts that's already working, then chances are rebuilding that would be pretty easy compared to just ripping a third member off a shelf or a random rear end and not knowing what's going on inside, if the parts are wrong mixer matched or broken pieces, etc. It could just save you a lot of problems. The last thing you should be doing is ordering parts right off the bat, because things can snowball, broken pieces, you might have the wrong stuff. First off, what I suggest is making sure you know what rear end you have. Do you have an 8-inch, 9-inch, 9 3/4? What year? So you want to be looking at part numbers. What pieces to that? What yokes, etc. So yeah, you can check a lot of these numbers online. This one I actually had trouble finding the numbers for, but a lot of these have numbers that you can look up. This is actually an aftermarket one, but this one, D2AW, is a common one, D2AWA. Okay, so right here we have two 9-inch cases, and this is the one out of the truck, and this is the one I was planning on using. And right off the bat, that was one of the curveballs I got thrown into that I wanted to talk about. This is a small bearing carrier, and this is a large bearing carrier. So these are two different sizes. These are like 2.8 something, and these are a little over 3. So these are not compatible. So when we bought the rebuild kit, we just bought a standard 9-inch rebuild kit. It was for this one, and the bearings and races were not meant for this case right here. So again, you would probably need to take this apart, run numbers, measure the races on the outside to know exactly what bearings you have. So again, this is more to the point that you need to get it apart before you go and order a rebuild kit, so you know what you have. Plus just inspecting, because you might get this apart and there could be damage somewhere that it makes this not even worth rebuilding, and then you need another one. Okay, spline is an important one too. So you know if you're rebuilding the one that's already in your vehicle, then it's a 28 spline, 31 spline, or aftermarket could be something different. But you need to make sure your spline matches up to your spider gears. So that's an important thing. If you're mix and matching parts, you don't want to mess that up, because then your axles won't fit. So there's a few different types of pinion supports. There's regular and Daytona. And regular just takes your standard bearings front and back. Daytona takes a larger bearing in the front. Also, it'll take a different yoke. Now here we have a standard one, standard Ford one, and a standard aftermarket one, and they take a regular seal. Now here's one from a 57 through 69-inch rear end that takes a larger seal. This is also interesting, which I'm having trouble figuring out because there's no part numbers. This has ridges, which looks like a stock Daytona style pinion support, but it takes standard bearings front and back. The other thing that throws this one through a loop is it takes a yoke that's unique to this style pinion support that will not fit these other stock pinion supports. So there's a depth difference on the stub end of the yoke that allows it to only fit this style. So this is something I'm still a little confused on, but it's something to look out for, because we couldn't mix and match yokes with this pinion support. And you see they make different types of yokes. They come in like 4 and 5 inch normally, and then you get small cap and big cap ones. But see, this is where the difference is in the stub end. You see how much taller this one sits than this one off the bench. And I guess it's common to have a different yoke for a Daytona style, but apparently there's a different yoke for the 57 through 60 standard pinion supports also, but I'm having trouble finding information on that. So for us to use this in the truck that we needed with the setup and the drive shaft, we needed to use this yoke, so that means we had to use this pinion support. So the other thing I wanted to discuss is completely take things apart and clean it, because you could do a quick visual inspection and you're like, oh, there's no damage, but then there could be, once you get it fully clean, there could be grooves on these pins, there could be damage somewhere in here, bolts could be damaged, could be chips on your caps or something. There's just, with the grease buildup and the oil, I say you want to get everything really clean and make sure exactly what parts you need, so when you order, you know exactly what's going on. Because if you need to order a spider gear set and something else, and then you ordered a wrong rebuild kit, and then you need a different seal, and then you need a different yoke, pretty soon you're almost at the cost of just buying a third member from someone that's already rebuilt. the little parts can snowball really quick and get out of hand. So that's why I think it's really important to take it apart, know exactly what you have, exactly what you need, any little incidentals that might be broken, like these thrust washers and stuff, and really be ahead of, and make sure you're really ahead of what's going on and that you're controlling the process. If anyone wants to comment below on what they know about yokes and pinion supports, things like that, that'd be great. Another thing I noticed is the carrier. I had two different carriers between these rear ends. One of them, the cross pin retaining pin, goes all the way through. On this one, it doesn't. And I noticed the spider gears don't seem to mesh back and forth between them, which doesn't really make sense, but I think it has something to do with how they're machined inside here, because one of these stub ends is longer. And so if you put this in a different style case, it actually rides different and causes binding in the spider gears. So you would think a 9-inch spider gear is a 9-inch spider gear, but there might be some differences between differential cases, and that's, again, something I'm confused on. I just think it's really important to either use existing parts or really know what mixes and matches well, because you could end up with some problems. And, you know, always just test fit stuff and inspect things really good. All right, another thing you want to look out for before starting is maybe thinking about which manufacturer of gears you're using. In the past, I've used Summit brand gears and they mark actual pinion depth on here. So I'm able to do the math and actually calculate the pinion depth off the pinion and the bearing bore sizes and get the actual axle center line and then calculate pinion depth off of that. This is Auburn brand gears, and this isn't actual pinion depth they have marked on here. And I called their tech line for support, and they were really no good. They just gave me a starting shim point to where to start, and basically I just needed to do it visually. So that's something to think about. Like if you want to do it off of pinion depth, then maybe you need to contact ring and pinion gear manufacturer and make sure that their standards meet what you want, because honestly I'm not going to be buying Auburn again. I'd rather just do the math and be one and done with it rather than have to play around with it. Another thing too is just make sure you know what you're getting into with tools. So you need like a dial indicator for checking your backlash and doing pinion depth measurements. Here's a little kit that came with the dial indicator and the tools for calibrating and checking pinion depth. This is just a standard little magnetic stand from Harbor Freight, and we use the same dial caliper with this that comes with this kit. Here's a tool I made for adjusting the adjusters. So all it is two wrenches bolted together that have one of them's angled so they come to the same point. And then I welded some pins in here so I can use it on the adjusters, you know, so I can get in here and spin these. You know, there's ways to get past all this stuff and other things, but you know, you just want to be prepared because you don't want to get halfway into the middle of something and then realize you don't have the tool you need. Like another tool that's real important is the dial caliper. The dial caliper is good for double checking that your dial indicator is set up right and checking shims, checking your race sizes. So this is another thing that's real important. And then all your basic hand tools like drifts and hammers and wrenches and sockets, all that stuff can add up quick if you don't know what you need. All right, I'm getting ready to rebuild this 9-inch rear end and also re-gear it. I'm gonna discuss parts, show it being taken apart and put back together, and show some things in detail that need to be understood. All right, so just a quick overview of the rear end. Here's the ring gear, the pinion gear. So ring gear's right here, pinion gear's in here, which goes through to the outside. You have the main housing and then the pinion housing. And this is where your O-ring and shim goes in here, and then the seal goes in here. Then this is the yoke that connects to the drive shaft and to the end of the pinion. And when you're adjusting the pinion depth, this is where you put the shim to get the right depth. So the ring gear connects to the carrier, and the carrier sits in the housing and is held in by these main caps basically. And then they have adjusters and adjuster locks. The adjusters will rotate in there and then give you your backlash to your pinion gear. And so you can get the right amount of distance between the two. Two quick ways to identify a 9-inch is a 9-inch pinion stub end is way bigger compared to an 8-inch. An 8-inch is about the size of a finger. A 9-inch is way bigger, and you can see with the pinion pilot bearing, I could easily get my finger through this, where an 8-inch you could not. Another way to identify it at the housing, really simple, is these bottom 2 bolts. You cannot get directly on with a socket. You have to get at them with a wrench. This is an easy way to identify it from the outside if you're not really sure. If you look online, there's tons of ways to identify and tell the difference, and also different ways to tell the different generations of 9-inch rear end. Some of the older ones, like 57 through 59, I believe, or 60, have a different type of seal that goes here that you would probably have to buy separately, or a different type of kit. And then also inside this carrier is where the spider gears are at. So we're going to take this fully apart and clean and inspect that also. There might be some concern for that because they're functioning, but they're making a little noise. All right, so this is the rebuild kit we got. So let's just start here in the center. We have the shims, the O-ring, the seal, pinion pilot bearing, the carrier bearings. We have the crush sleeve, pinion bearings, the ring gear bolts, Loctite, and we'll put Loctite on the ring gear bolts and the adjuster locks, and then the paste to test the gear mesh after we're done, and then copper washers for holding the third member onto the housing, and then pinion nut. You're only really supposed to use the pinion nut and the crush sleeve once, so you need to make sure you get the preload set correctly, and then it's just one and done with that. It has a new locking clip for the pinion pilot bearing in here also, so that's good. This is definitely one of the better kits I've seen. It's pretty thorough. A few things you want to do before this comes apart is, if you're reusing this the gears out of this, you're going to want to mark it. So you're going to want to get in there, you're going to want this clean, and you're going to want to get in there with some sort of paint pen or polish, maybe nail polish or something. Anything is going to stick to it really good, and make sure to mark where they touch, so when you put it back together, you're going to put it back together in the exact same spot. That's an old Ford recommended technique to make sure that they go back together correctly. The other thing you're going to want to do is measure your pinion depth. So you can go ahead and take, once you do that, you can go ahead and take the carrier out and take this cap off, and then you'll take your pinion depth off of this deck height to here. And then also, once you get the shim out of the bottom, you're either going to want to set that shim aside or take a measurement of that shim and make a note of the measurement of that shim, because when you put this back in, you're probably going to want to reuse the same shim, and you need to duplicate this depth. So that's really important that you duplicate this depth and mesh the gears back together in the exact same spot that they came apart. So mark them in a way you're comfortable, so you know that they're going back together exactly how they came apart. Since we're reusing new gears with a new depth, we don't have to worry about that. We can basically just take it apart. What I'm going to do though is mark these caps. So I'll put like a 1 dot mark here, 1 dot mark here, and I'll put 2 dots here and 2 dots here with a punch. And what that's going to do is help me know that the orientation of these caps when they go back together, in case they get mixed up during cleaning and moving stuff around. And so you could decide to do different techniques, but I know this one's worked good for me in the past, so I put 1 dot here on the cap, 1 dot on the housing. Now on this side, 2 dots on the cap, 2 dots on the housing. So like I said, if they get separated or whatever, I know it's going to end up right back in the same spot it's supposed to be. Now at this point, like I said, because I don't need to take the pinion depth or mark the gear, I can just start stripping it and taking it apart. And in case you didn't notice, having this third member in a stand makes it really easy, because I can rotate it around and work on it. And what these are just some L brackets from some seats we ordered a long time ago. And they already came bent, and we just drilled holes in it to mount it to this. And these are the same brackets I used in the 8-inch video. And then we just spread the engine stand to the right width and just bolt them in, and works pretty good. Then just bolt them in right there. This is something you could easily, you know, find some scrap metal or buy some sort of metal or make something to mount it to an engine stand, and that's a pretty affordable way to get a really good mount with the engine stand you have laying around. All right, so I got the main housing pretty much stripped with the carrier out and the pinion housing. I'm going to take this pinion pilot bearing out now, and you got to be careful. There's a clip on the other side. This one appears to be missing it right now. Sometimes you can hammer those out, but it's best to probably remove that clip first, and then you can go ahead and hammer it out. And I have this tool right here. That's the perfect size. But you could probably use a socket and some other things, but these things are pretty cheap. So I'm gonna go ahead and punch that out. And right now, here's the carrier sitting out with the ring gear. Here's the bearings. Here were the races that go on the outside of the bearings. Here's the shims. This rear end was set up incorrectly. I think it was just jumbled parts together. So I'm not reusing these shims, so I wasn't careful when I took it apart. But if you're maybe needing to reuse the shims, maybe be a little more careful when taking this housing off. After I'm done getting that pinion pilot bearing out, I'll go ahead and pull the ring gear off this. The bearings need to come off. This housing needs to be split apart. Then this pinion housing needs to have the yoke removed, and then it'll all come apart. And then again, the bearings taken off and everything. All right, so where the pinion bearing just came in, it doesn't have the ridge for the clip like I'm used to. So I don't know if something's wrong or if this is a different, these housings don't necessarily have it. I'm gonna have to do some research on that, but I got that out fine. And an important note, when you're reinstalling these, you wanna be careful because I've hammered these in too hard to where it busts this back edge. So that's just something to think about. I got the pinion housing clamped down in the vise. And now I'm removing the pinion nut right here. I'm gonna have to clamp onto this with some big pliers and get this off. Luckily, this was already kind of loose, so it's not gonna fight me too much. But you might need a really good set of pliers, pipe wrench, channel lock, giant crescent wrench, something to really hold onto this good, especially when you're putting it back together. So I'm gonna go ahead and get this apart really quick. All right, I just took this apart, but it didn't record quite right, so I'm just gonna show it coming apart. All right, here's the pinion nut. Here's the yoke. And then the housing will separate from the pinion gear. And then when you do that, what's left on here is the crush sleeve. One-time use crush sleeve. And the bearing. And then in the housing still is the other bearing, the races, and the seal. So we're gonna go ahead and remove this seal. Then we can get the bearing out. And then once the bearing's out, we can go ahead and hammer, get a drift and hammer both of these races out. Well, that seal was not coming out with the slide hammer, and I wasn't paying attention. I took the chisel. I probably should have used like a putty knife or something, but I took the chisel to get between the seal and the housing, and I guess I wasn't paying attention very good, or I wasn't focusing. I thought this was part of the seal right here, this edge, and I hammered down on it and I chipped the housing. More than likely you would want to replace that, but the seal does seal past that chip. But now you saw the bearing came out and then it had this metal plate, and now I'm going to go ahead and take these races out. with a drift. I'm going to get in here and hammer them back and forth on each side until I can get them out. All right, so there's the races that came out. So this is all stripped. I took out the O-ring. That was right here too. There's the O-ring. So this just needs cleaned up now, and then we'll prep it later for getting it all back together. I'm going to go ahead and remove the ring gear from this and get this housing apart so we can check out the spider gears. All right, I had basically unscrewed all the bolts that were holding the carrier to the ring gear. And then once that was done, I went in through the hole, which was inside here, and I just tapped it until it popped off. You could probably do it on the outside too, but this works okay. And I'm not really too concerned about this because we're not reusing it. Now I need to get this pin out right here. This cross pin that's holding the pin that's holding the spider gears. So I already got it out a little bit. I'm gonna finish tapping that out. It's a little flat blade. There we go. All right, once this cross pin is out, then we can pull this pin, but it's not sliding out super easy. So give this a little motivation. There it goes. And now this should separate. Might have to get a putty knife in here and separate it. But yeah, we'll give it a little motivation. You know, and try not to break anything like we did before. That'd be nice. There it goes. Possibly get this up with a screwdriver now. Yeah, just prying around the edges. There we go. These ones don't look bad at all. Then you got these plates too that we got to reuse. But yeah, it's definitely grimy in here, that's for sure. And then there's also these ones that go on the cross pin section. So, and these can, when you're putting the pin in and out, if you're not careful, you can damage these. I've done that before. Oh, see, that's probably where that sound was coming from. This one's cracked. I know it was it had like a rough sound when I was turning it. Something didn't seem right, so. All right, well, that's good. We got that all apart, so we can go ahead and get this clean, along with the other stuff. And then besides pulling the bearings from the carrier and the pinion bearing, we pretty much got it all disassembled. We broke one piece. We did find this piece was broke. And other than that, everything seems to be in pretty decent shape. We just gotta, get it clean and put back together. Basically, the next step is just get all this stuff in the parts wash and get it clean. I'll take the bearings off after I clean everything, and then we can discuss putting it back together. Okay, so we ended up buying another pinion support. This one is the non-Daytona, so it's a regular stock housing, so we can use all the same size bearings and races. So you want to look out for that. If you have to get one of these, the stock ones are kind of hard to find. This one's actually made pretty good. I think it's made by a company in India, but I took a bunch of measurements on it. It's pretty much spot on with the original, so I'm happy with this. Another problem I ran into, which I didn't notice until I got this really clean, which kind of reinstates the fact that everything needs to be really clean and inspected thoroughly before we order parts, because I missed that this pin had grooves on it. And one of the spider gears that rode on that has grooves on the inside. So we're going to go ahead and order a spider gear kit also. Other than that, so far I got everything cleaned and ready to be put back together. I cleaned everything in the parts wash, took a wire brush to everything and cleaned up all the threads. The last thing I need to do for assembly is go ahead and take these bearings off of this old carrier. Once the bearings are off, everything's pretty much clean. Just recently we got a Harbor Freight bearing puller, so I'm going to be using that and see how that goes. Alright, so I went ahead and got the first bearing off of this right here without too much trouble. Here's the press setup, so it just goes under the bearing and then with the jack screw. The only problem is it's hard to hold, so I had to clamp it in the vise, like sideways. I just put a piece of cloth or shop rag in there so it didn't mar up the surface of this. I used this 1/4" metal first and it started to dig right through it. So then I used this like 3/8 metal, and again you can see it put a divot in it. But then that was ended up being too short. This is an old insert for a pinion bearing that we use to help press pieces out. So I'm gonna have to put this here. Here's like a metal slug I found recently. That'll go on top of that. And then this, the jack screw can go on here. I actually have it this way to work. Yeah, unfortunately I wasn't able to get a good video of this Harbor Freight puller. I was able to use it on this one, but on this one there's these ridges right here, and it prevents you from getting exactly where you need to be, and then it causes the bolt to be too short. So if this had a longer bolt, it could probably get under there. I ended up using this other bearing splitter in the press, and what I'll probably do in the future, probably drill this out and adapt it to this Harbor Freight kit, so we can use this one with the same setup and jack screw. I have the pinion support or pinion housing. I'm going to go ahead and install the new races in it. And I have this tool that can install it. And I went ahead and just lubed it with a little WD-40. See if I can't get it started just a touch. All right, that's going in. It's going in kind of crooked. Alright, I started to drive it in a little crooked, so I had to straighten it out, but that seated in there really good. You can almost see the WD-40 like smoke or something right when it bottoms out, so that's good. Now I'm going to flip it over and do the other side. basically there. I'm going to go ahead and tap it. So I've never had that much problems with a race trying to go in crooked, but I've never had a new housing. So I wonder if that's part of the problem. So, but yeah, that fought me. But yeah, it's seated in there good. Probably would have used the press on this knowing I was going to have to fight it that much, but got to clean it up really good because the aluminum shavings from the driver bit kind of got spread everywhere, so I need to make sure this is cleaned really good. Then I can go ahead and start installing the pinion on here and then do the pinion preload. Alright, right now I'm going to go through and remove all these casting marks. It's supposed to help relieve tension in here, so I'm just going to grind these down and also prevent flaking. So if some of these can sometimes come loose over time and then could potentially cause a problem. So I'm just going to go ahead and grind all this stuff down. Then there's also a trick to just barely grinding the edges here and the same edges on the cap, and that's supposed to help relieve tension also and just make it a little bit more reliable over time. Where it cracked on its own right here, I might go ahead and clean that up a little bit also. But I wonder if this is part of the beveling technique, because you can see where it chipped right here. So just beveling this edge maybe takes a little bit of the tension off, but you can see it's been like that for a long time. Alright, so here's the case. I ground out most of the casting marks. I beveled these edges here and on the caps. So all along here, just all the way around. So I'm pretty happy with that. Yeah, and there's the caps, just took a little bit of the edge off. And how I took the casting marks out on that, you can do that on here, like get in these passageways and file it down. This one is actually way better than stock, so I just went ahead and left it. I didn't really go and file at it. But it is important to get in here and look for possible parts in the oil passages in here that can break, like down in there too. This one's actually cut a little different too, so it actually takes some of the possibility for breaking out. Alright, so now I'm getting ready to install the bearings on the carrier, both sides of the carrier and on the pinion. And what I did was I took the old bearings like this and I cut the cage off. So you can just nip it with some wire snips or some sheet metal snips, the top and bottom, and then pry the cage off carefully. And then you're left with just the inner piece. Now what I did was I ground down the inner piece so it'll slide over this without getting stuck. And I'm going to use this as a tool to press the bearing on. So I'm going to put the bearing on, and then this will be able to match right up against the edge of it, and then this can go on the bottom of the press, so when I press it through it'll push on here, and then once it's all the way pressed this will be able to just come off. I did the same thing with the carrier bearing, and so I can use this as a tool to press the carrier bearing on. And this one probably didn't need ground down, but if it just barely catches that lip it could be a problem. So I went ahead and did the same thing with this so it can go fully on without being caught up. So I'll use that as the same right here. And then I can press the bearings on. In the other videos I did with the 8-inch, I had a piece of pipe that I used to hammer this on. And I used a drift and hammered it on both sides. That actually works just fine. I'm just trying to get a little bit better with what I'm doing and using the press more. All right, mostly got the bearing on all the way with the press, but it needed hammered on the rest of the way, so you could easily take like a drift and tap it on each side, or a piece of pipe, or like the old bearing insert and then like piece of pipe or something. That's what we ended up doing. But now I'm getting ready to install pinion onto the housing. So then the bearing's on all the way. We'll go ahead and put the housing on. Then goes your crush sleeve. Then the new bearing, this washer. We'll put the seal on, we'll put the yoke on, then we'll put the nut on, and then we'll go ahead and set the preload. And the goal with that is we're going to tighten it until we stop feeling the pinion move around. Then we know we're getting tight, and then we'll do it in really slow increments until we're getting the right amount of rotational inch-pounds. And we're shooting for 25 inch-pounds rotational. And then that'll go on the yoke, this other washer, and then the new yoke nut. For right now, I'm going to try to go ahead and just tap this down a little bit so we can get it started. And then drawing the bolt in should finish it if need be. Alright, so I got the bearing on, I got this oil slinger in. Just need to put the seal on. I'm going to put some gasket sealer around this and tap the seal on. I prefer to do the rotational force with the seal because of the fact that the crush sleeve is only one-time use. So if you use that crush sleeve with the seal not in place and have to take it apart, then theoretically you're supposed to replace that crush sleeve again. So last time I had a piece of PVC, but I couldn't find it, and I think the seal size was different, so I just went ahead and tapped it in with a hammer this time. I probably could use a better tool or something, but this worked well. Alright, I'm going to go ahead and grease this up so it can slide into the seal really good. Alright, beautiful. Then the washer. And then the new bolt already has like a Loctite on it. So I'm going to go ahead and clamp this in the vise and start tightening this down. And then I'll alternate between tightening it and testing the preload. Okay, right now I have the whole pinion support assembly together. So we had pressed the bearing onto the pinion. We put the races in the pinion support. We went ahead and put the pinion in, put the crush sleeve in. Then we put the other bearing on from the top. We put the oil slinger in. Then we put the seal on. We put the yoke on. Then we put the nut with the Loctite on it. And this nut already has Loctite applied. So right now, I just tightened it down by hand, and I don't know if we can see it, but there's still a little bit of play in here. So what we want to do is tighten this down until this play is gone. Once the play is gone, then we know that we can start measuring rotational force. So we'll go ahead and clamp it in the vise here while we're tightening it. Once we get it kind of tight, we'll clamp it here and test the rotational force. And then we'll have to keep going back and forth. We'll just tighten it just a little here on the yoke, and then we'll keep measuring it. I believe the Ford spec is 22 to 30, something like that for a new bearing. Most people say 25 for a new bearing. Some people argue about whether you should use the seal or not. The crush sleeve is one-time use, so you should be able to install everything at one time and be done with it. So in my opinion, the seal should go in with the crush sleeve, do it all at once. The seal will add some drag to that reading, so we could easily go up to 27 to 30, still be within Ford spec and accounting for the seal. So honestly, I'm gonna be happy anywhere between 25 and 30, but we should do 25 at the minimum because that's the recommended spec. If you had used bearings, you could do a looser spec. Just look up what would work for your application. So we're gonna go ahead and tighten this down right now. Oh yeah, this is the horribly horrible part. See, this is one thing I learned from doing this a few times is you do this until the slop's gone, and then you start measuring preload. All right, so I got the slop out of it. Now's a good time to go ahead and check the rotational resistance on it, and then just start tightening it in small increments until we get the right amount of preload. This is really loose right now, but I'm just gonna go ahead and get a starting point. And what I'm using is just a basic analog inch-pound torque wrench. And then we're gonna spin this and see how much resistance it pulls, and that'll tell us how much inch-pounds in preload we have. Yeah, see, like that's not even registering. All right, so that's not even registering on that, so I'm gonna go ahead and just keep tightening it down in small increments until we get where we need to be. Could probably go more. This is one of those things that's better safe than sorry. It's pulling like 5, so it is starting to gain some resistance. Okay, so I kept tightening this until I finally got some resistance, and it got up to about 15, and then I knew it was going to be needing to be careful. Then I gave it one more nudge, and it got it up to 20. And I gave it another little half nudge with the breaker bar, and then I got it up to basically right at 25. It's a little hard to see, but it's pulling 25 steady on here. Takes about 25 inch-pounds of rotational force to turn this. So that's what we're looking for. I could go a little tighter, I think, with the seal, because like I said, I think Ford spec is up to 30. But for the sake of not having to redo this, I'm just going to call it at 25 because 25 is a pretty standard thing that people agree on. Because if I do go over, then I would have to redo it. And if you felt this at 25, it's really stiff. It's stiffer than you think it would be. This will work well for keeping preload on it. All right, I'm getting ready to install the pinion pilot bearing into the case right here. And once we get the bearing in, we'll go ahead and put the retainer in with the teeth facing up. And I'm just going to use this bearing and race installer tool. So I'll just lube this up. And be careful with these because edges on these are pretty sharp. And it should fit in. Then we'll just go ahead and tap it in gently till it bottoms out. We should hear the sound. And this is something you want to do really careful because the case isn't that strong. And you could easily tap this all the way through if you're not careful. Or if you keep hitting it hard, once you bottom it out, you can break out the back of the case. Okay, it's pretty much fully seated. I'm gonna give it another little couple taps for reassurance. All right, now I'm gonna go ahead and install this clip. And you make sure you wanna ride on this edge and not on the actual prongs itself. Pretty much all it needed. Looks pretty decent. This edge looks a little high over here, so I'm gonna try to get that side down. Yeah, that looks better. And now that's in good with the bearing and the retainer. Now I can start getting the carrier ready. I'm getting ready to install the spider gears back into the carrier. I have some new thrust washers. We know that these are right for the axle. We have the cross pin and the cross pin retaining pin. I already test fit this, made sure it worked. I noticed there was some problems with these gears fitting another carrier, which I'm not really 100% sure about, but I know this works. This is what came apart and worked, and it's gonna go back together. I will go ahead and just lube these up a little bit when I put them together. And if you notice, this case is actually a little different because a lot of the 9-inch and 8-inch have the hole that goes all the way through for the retaining pin. This one doesn't have that. So, but it is marked ever so slightly where you could see the pin was. So I'm gonna make sure to put it back in the same way that it came off, like that. And after some test fitting, if I remember right, this actually fits better going backwards. Yours might be different. And you really want this to go through smooth, just like that. It's already through. If you have to start hammering on it and stuff, there's a good chance one of those spider gear thrust washers is in the way. So probably need to take it out and make sure everything's aligned properly. Now on a normal one, you would put the caps back together before putting this pin in, but on this one we can go ahead and install the pin now. So I'm just gonna go ahead and tap that in there. Yeah, if that needs to go down any, it'll go down when I pressed it. And just with all this stuff, this whole surface, the back of the ring gear, everything, you want to make sure there's no scratches or things. And I just clipped that ever so slightly, so I'm going to file that. It's probably not a big deal because that's where it more overlaps, but yeah, you don't want to. Don't want any problems. All right, so the pin's in there. Real good. And then this is like flawless how it feels. This is, you know, there should be no binding, no question that it's like perfect mesh. So go ahead and put the other thrust washer on. Now, like I said, we'll make sure these are lined up. So this is right there. Right, yep. There we go. Go ahead and tap this on. All right, that's on pretty good all the way around. Any little bit that needs to go down will be fixed when I put on the ring gear. So now we're going to get ready to install the ring gear. All right, so I went ahead and took a drift too, and I kind of tapped it down in here and tapped it sideways, and I made sure I got this lined up perfectly centered. And I got the ring gear here, and I'm going to go ahead and just sit it right down over it to try to line up the holes. And that drew it in pretty close. So I'm going to do is take 4 bolts and use these to draw it in the rest of the way. And this is before the Loctite and final sealing. So I'm just going to go around and tighten these little by little. And what that's going to do is slowly draw the ring gear onto the carrier. And I want to go evenly. It's kind of off right now, so I need to do this side a little more. All right, you can see the ring gear now is fully seated on here. So I'm going to go ahead and take these off, probably spray some brake cleaner in here to kind of clean them up a little bit, and then we can apply Loctite to all 10 bolts and torque them down. Okay, so I have the carrier with the ring gear clamped in the vise with some rags so it doesn't mar it up too bad. Because to torque this, it's pretty rough, so you need to, have someone hold it or put it in a vise. I got all the bolts ready. I'm going to apply red Loctite to them. I'm going to hand tighten them first, then I'm going to torque them to 25 foot-pounds, then 50 foot-pounds, and then 65 foot-pounds. Doing a star pattern the whole time, like jumping across, and when I'm done, I'll go back through and just double check all the torque of everything. Okay, so that's 25 foot-pounds, now 50, and then 65. All right, what I wanted to do was set up actual pinion depth off of the measurement by finding that actual axle center line and then taking the pinion depth and calculating that correctly. This is an Auburn gear set, and they don't have theirs marked with actual pinion depth, and I called their tech line and didn't really get anywhere much past they gave me a starting point to shim at, and then I had to work from there. So I ended up setting this up visually I'll kind of talk about how I did that. If you want to see how to do it with the measurement and finding the actual center line, I have another video on rebuilding 8-inch and 9-inch rear ends, and I go over that in the video. So basically what I did was I started with, like, say a 20 thousandths shim I put in, and then I came in here and I did the backlash and I tested it. And then depending on where the mark was, I knew where to move up or down in what direction. So then I put in another shim that was closer to what I wanted. I then recheck backlash again, and then I do the mark again. And I just kept doing that till I got the right, I narrowed it down to basically the right area. And then I messed around with like 3 different sizes until I got exactly where I wanted. And this is the result I got. So I'm pretty happy with this. It's showing a little bit of full tooth contact because you can see the edge, but then it's favoring the center. So that's pretty good. Your drive side is more important to center on. And then the coast side is favoring the bottom a little bit, but that's okay. Like I said, it's more important to focus on the drive side. What I'm gonna do is go ahead and take this apart, show it going together one last time. So after you mess with it, you'll put it back together the same way that I'm doing. Basically, to test it is the same as putting it together. So I'm gonna go ahead and rip it apart, but I know the shim pack that I need. Then I can set backlash again. But before that, I'm going to set preload on this. And there's a few different ways to do that. You should be measuring the cap spread, and there's special tools that come up off of this, like you need like stands. And so what we're gonna do is kind of not the exact by the book way, but it'll definitely put preload on here, and it's worked well for me in the past. But once we get the preload set on here, then we can go ahead and reinstall it with the shim pack that I know is good. And then we'll go ahead and reset the backlash, and then we can test the mesh one more time just to make sure everything's good, and then we can torque and Loctite everything down where it needs to be. All right, this book I have shows a real good example of visually setting up the gear mesh. The side that's angled out is the drive side, and the side that's angled in is the coast side. The top of the gear is the heel, and the bottom of the gear is the toe. It's good to be centered on the drive side, and you can have the coast side favoring the toe a little bit. So that's okay. Ideally, you'll get center, but it can favor the toe on the coast side. So what you'll notice is the gears, when they're out of mesh, they'll start to move opposite ends of each other. So see how these are opposite ends of this image? So they'll almost like rotate opposite of each other. So this will move down while this will move up. And so if you're too far, this will move so far down that this one will move up. So the idea is to move it until you get the right center point. If you're favoring the heel, which is the top of the gear, then that means you need a thicker spacer needed. And if you're favoring the toe end, which is the bottom or inside of the gear, then you need a thinner spacer. So this is a good way to just visually figure out where you need to go. And you might want to jump up in maybe 5 to 10 thousandths increments, somewhere between there, depending on how horribly spaced you are, rather than like 2,000 increments. So jump up in like 5 or 10,000 increments until you get really close where you want to be. And then right here, you can maybe move around 2 thousandths at a time, up or down, and until you get it exactly in like the sweet spot. All right, these were oiled a little bit, but I should have oiled these adjusters when I was testing the shims. But that's what I'm gonna do right now. I'm just giving everything a good final little check. I'm gonna go ahead and oil the adjusters, oil the bearings, just so it has some good oil to work with when it first gets going. And then I can install the races with the adjusters, and get the caps on. And like I said, I marked the one cap so I know where it goes, because it can only go in one spot. And then this one only fits one way, so it'll go the opposite way of that. Then I'll go ahead and set the preload. One thing you want to be careful is don't force these caps on with the adjusters. Make sure that you're getting them fit properly. Might need to adjust the adjusters ever so slightly till you get the cap to fit exactly where it needs to be. It can be kind of a pain, or maybe put them on and thread them in. There's probably a couple ways you could do it. All right, I got that sat in there. And we can put the caps and the adjusters on. Go ahead and oil these up a little. Like I said, I should have had these oiled when I was testing it and I forgot. And you want to make sure these aren't cross-threading in, that they're threading in straight. All right, those are in. All right, so I have my mark right here. So I know this is the cap that goes on this side. And somehow I got that one on first shot. Just check it with my tool. Yeah, that's in there really good. See if we have as good a look on this side. But you'll feel it, the bolts will be binding when they're going in because the threads aren't lined up exactly. Well, that one actually just went in perfect too. But yeah, you'll feel it, the bolts won't be threading in. It just won't feel perfect when it's going together. And you could actually fight that for a little bit and then yeah, check, make sure it threads fine. So we'll just snug these down. And this is a tool I made. It's just 2 wrenches bolted together. One has an offset so they meet in the same point. And I welded 2 bolts right here, or 2 like studs, so I can get in on these adjusters. So I'm just gonna go ahead and snug these up for now. Nothing too tight, I just want them to be snug. Okay, and you see how that has a lot of free spin in it? We don't want that. Okay, so I'm gonna go ahead and torque these down halfway, which is 40 foot-pounds. When we torque these to 80, we'll double check, you know, everything after that, because sometimes the torque can affect the result. Okay, as you see, we're getting a lot of free spin out of that. So we want to go ahead and tighten this up so we can get a lot of that free spin out of it. So that's good. We get a little bit of free spin, but it stops shortly after. That's basically what we're looking for. What that did was it actually spread the case a little bit, so that's the case spread. And then that gives it about a 4/1000 case spread, I believe is what we're looking for. And like I said, even if I do measure it, I don't have the proper setup, because you can actually set up a dial indicator to measure, but at an angle, it's not gonna get the proper reading. Here's a section that talks about case spread. I'm not gonna get hugely into it, but your instinct might be to put a dial indicator sideways with 2 posts coming up. But the book shows how that's a problem, where you might get a reading of 12/1000 up here when it's actually 4/1000 case spread here. So what you need is a thing called a wiggle bar. And what that does is it brings the sideways measurement down closer to the case. You're basically spreading the caps apart from each other and you need to measure that. So to measure it correctly, you need a setup like this. So right here it shows the 2 verticals is wrong and then having the wiggle bar is the right setup. Unfortunately, I don't have this setup, so that's why I just tighten it until I get a preload that I can feel by hand. This is pretty good. I might go a touch tighter, but I'm happy with that. Yeah, so it still free spins, but it stops shortly after. So it's exactly what we're looking for. Now when we reinstall the pinion gear and move the backlash, we just make a mental note of where our adjusters are and then put them in the same position, like move them accordingly together, so we maintain that preload. And this is the same way you would check the mesh. Put in the ring and carrier first, followed by the pinion, and then you can check your shim count. So these are where the shims go between the 2 cases, the pinion support and the main case, carrier case. And right now I'm going to install it without the O-ring, because that does put some pressure on it, and if there still is a problem, this might need to come out. So I'm gonna just go ahead and install it without the O-ring for now. And that'll be one of the last steps we do, is put the O-ring on that. And you could put like 3 bolts in here or something just for the testing, but I'm gonna go ahead and just do 5, all 5. What you might wanna do is secure the pinion, but since we have new bearings and the preload is so tight, it stops it from moving. As you can see, it's got quite a bit of backlash, like over 30 thousandths. So, and our goal is somewhere between 8 and 10 with this, because we're following the specs of Auburn. They want 8 to 10. So that means the ring gear needs to move closer to the pinion. So we'll go ahead and back this off, and you'd be surprised, a couple notches could easily only go like 10 thousandths. So, and I lined these up pretty decent with the holes. So to keep the preload going, we'll basically back this off too. We'll tighten the other one too. And then we'll measure it again, and then we'll maybe just go one at a time or half of one at a time, you know, back it off, tighten it until we're getting the right amount of backlash that we're looking for. So we're going to go ahead and check backlash again. And you want to get it to where you're hitting it straight up right here. And I like to measure it on the drive side, because you get a nice little flat spot right here. And we're going to zero this out again. And now we're getting under 30 thousandths. So hitting it, those 2 marks only brought it down like 5 thousandths. So we're gonna have to move it in quite a bit more. Okay, so I'm gonna go ahead and keep, you know, loosening this side and tightening this side in the exact same amount until I get the right amount of backlash, and then we'll check back in. I kept adjusting it until I got the right amount of backlash. So right now I'm getting about 9. So it goes to 0 and it goes to 9. So that's perfect. We wanted 8 through 10. So now what I'm gonna go ahead and do is give these a final torque to 80 foot-pounds, and then I'm going to recheck the backlash in 4 different spots around the ring gear and make sure there's no variation. Okay, so I went ahead and checked the backlash in 4 different spots, and I was getting somewhere between 9 and 10 thousandths depending on where I did it. So that's good. Really shouldn't have more than 1 thousandths variation. That's pretty normal. According to some books you read, you can have up to 3 thousandths variation. If you start to go over 3 thousandths, you need to set up a dial indicator to the back of the ring gear and rotate it and check if there's any variation in that. There could be something wrong. It's not seating properly, something like that that's causing too much variation. But right now we're running 9 to 10 thousandths backlash, which is perfect for me because we're looking for 8 to 10. So now what we're gonna do is go ahead and mark these with paste again and double check that everything's right between pinion depth and backlash. Just make sure it looks good how we expected. Once we double check that that's good, we can work on the final assembly. Okay, to test this, we only need to put like the gear marking compound on like 3 or 4 gears. So we'll go ahead and put it on both sides. All right, that's more than good. And then you want to rotate this like at least 4 or 5 times in every direction. And then you want to also put pressure on the back of the gear so it simulates like a load being on it. I'm going to go ahead and do this more than 4 or 5 times just so we can really see the pattern that's going on there. Okay, now we're going to go back and do it the opposite direction so we can get the coast side as well. Okay, so we can see right here, I'm still getting almost like a full tooth contact because you can see it's removing the heavy marking compound that's putting a line all the way down. Then it's favoring the center because it's wearing it away completely right there. And then on the back, on the coast side, we're getting it just favoring the toe end, which is good. So this is exactly how I had it set up, so we're basically right where I wanted it to be. Now if you got to this stage and you had some problems, then you might need to go back and readjust, you know, your shims or your backlash and just double, triple check everything. I went ahead and installed the O-ring on the pinion support too, and then I greased it all the way around, and then once I put it in, I put another little thin layer of grease on this side so it'll go in real smooth. All right, we're gonna go ahead and install this. And you see the O-ring creates tension on it. So we're going to use the bolts to draw it in. This is kind of why you want to do it last. You don't want to take this O-ring in and out a bunch of times. So, you know, we're just going to snug the bolts for now. Then we'll just go ahead and use the bolts to draw it in. So we went ahead and used the bolts to draw it in. Then we'll go ahead and torque these to 35 foot-pounds. All right, I'm going to go ahead and torque these to 35 foot-pounds. I'll just go back and check them. Now flip this over. Now I'm going to go ahead and install the adjuster locks. I try to line these up the best I can, but sometimes with the backlash they might be a little crooked. But there is quite a bit of play in this. It's okay if it's not spot on, it'll normally work fine. But we're going to go ahead and do Loctite on this and tighten it to 20 foot-pounds. All right, so now I'm torquing these to 20 foot-pounds. There we go. They don't need to be too tight. All right, there we go. Now it's ready to install back in the car. We don't have to worry about taking this off. This will be fine. The gear marking compound. You know, you just want to also just double check things. You know, we torque this. All this stuff's good. We double, triple check that. We just tightened the pinion gear. We made sure the O-ring was on. Our shims were in it. If we wanted to one last time, we could go ahead and check the gear mesh. But we should be good. Yeah, so it's ready to install. If you guys have any questions or need help with anything you're doing, just let me know. All right, bye.